Welcome back to the deep dive. If your current mission involves getting your head around Azure identity, then you have come to the right place.
Especially if you're wrestling with that classic decision. Do I use a managed identity or a good old-fashioned service principal?
Exactly. And this isn't just, some academic exercise. Getting this wrong is the difference between a secure, clean cloud architecture and one that's just, well, a mess of secrets and compliance headaches.
It's a foundational decision point. And if you're prepping for the Microsoft AZ-104 exam, you know this is a huge area. They expect you to know more than just the definitions.
Oh, for sure.
You have to understand the why, the security model behind each one, because they are fundamentally different ways for an application to prove who it is.
And the exam loves to poke at that difference, right?
Uh-huh.
We hear it all the time from listeners. These identity scenarios, they're some of the trickiest questions because they feel like two tools solving the same problem.
They do.
So today, we're not going to do the 101 level stuff. We're jumping straight into what we're calling the battle pack.
I like it.
Yeah, a scenario-heavy deep dive. The goal here is to give you surgical clarity, so when you see one of these questions on screen, you just know which tool to reach for.
And our mission today is really to give you a powerful decision framework. We've got about 15 of the most common scenarios lined up, and we're going to focus on that one critical, non-negotiable distinction.
Which is?
Whether the identity is operating inside the Azure fabric or trying to get in from the outside. If you get that, you're halfway there.
Okay, let's frame that up then. The core differentiators. If I had to boil it down, managed identity is the zero trust hero. It means zero secrets. Zero. Because Azure handles everything behind the scenes, the rotation, the distribution, all of it.
Whereas the service principal is the traditional way in. It needs a key to the door.
A credential. So a secret, a certificate, something tangible.
Exactly. And that single difference, credentialless versus credentialed, changes everything about the security posture.
Let's get into it.
All right. So we have to start with the simplest, most powerful rule in all of Azure Identity. I mean, this is the absolute non-negotiable.
The golden rule.
The golden rule. Get this right, and you can honestly eliminate 50% of the wrong answers on an exam question before you even blink.
Okay, lay it on us. What is it, and what's the actual mechanism that makes it a rule?
So the rule is all about location. It's structural. A managed identity depends on an internal Azure service called the Azure Instance Metadata Service, the IMDS.
IMDS, okay.
And this service, this endpoint, it only exists inside an Azure compute environment. Think VMs, app services, functions, that sort of thing. It's not on the public internet.
So a resource running in Azure talks to this local thing on its own network.
Exactly. The VM, for example, makes a request to a local non-routable IP address, the IMDS endpoint. The IMDS then says, okay, I know who you are, you're VM123, and it goes and gets a temporary access token from Azure AD on the VM's behalf.
Wait, so the physical location is the key. The identity isn't proven with a password, but by virtue of being able to talk to this special local service that Azure provides.
You've got it. The workload asks its local host environment for a token, and the host environment which Azure controls vouches for it. So that brings us to the foundation of the golden rule.
If you can't talk to IMDS,
you can't use a managed identity. End of story. If your code is running on your laptop or an on-prem server or in a GitHub runner, it fails at step one. It has absolutely no way to reach that endpoint.
Which means it has to use a service principal.
It must.
That makes so much sense. It's not just a policy, it's an architectural limitation. The way the token is retrieved dictates everything. So if the question describes anything outside that Azure fabric, we immediately know what to do.
Right. We pivot straight to credentialed access.
Okay, let's put that rule to the test. You said there are 5 key scenarios where this comes up.
Yep. Let's start with a really modern one, something everyone's doing. Scenario 2. The GitHub Actions pipeline.
So the situation is a CI/CD pipeline running in GitHub Actions. It needs to use the as CLI to deploy some resources to your Azure subscription.
Right. Maybe it's deploying a web app. Maybe it's updating a network security group.
Okay, well, the environment is GitHub. GitHub is external.
Check.
The pipeline needs credentials to log in, so the correct choice has to be a service principal.
It has to be. But here's the follow-up question the exam is testing you on now. How do we do that securely? Because the old way, storing a client secret in GitHub secrets, that's risky.
Yeah, that always felt a bit fragile.
It is. So for the AZ-104, you have to know that the best practice has evolved. We don't use secrets anymore if we can avoid it. We use Federated Identity Credentials, OIDC.
Okay, let's slow down and break down OIDC, OpenID Connect. If I'm not storing a secret, how on earth does Azure AD trust my GitHub workflow?
It's all based on a trust relationship that you configure. So first, in Azure AD, you go to your app registration, your service principal, and you tell it, I trust tokens coming from this specific GitHub organization, this repository, and maybe even this specific branch.
So you're pre-authorizing a source.
Exactly. Then, when your GitHub workflow runs, GitHub's own OIDC provider generates a special short-lived token. This token contains claims, bits of information saying, I am the workflow from this repo on this branch triggered by this event. And crucially, that token is cryptographically signed by GitHub.
So instead of my pipeline handing Azure a password, it hands it this signed token from GitHub.
Precisely. The pipeline presents that signed token to Azure AD. Azure AD looks at it, checks the signature against GitHub's public key to make sure it's legit, and then checks the claims inside.
Is this from the repo I was told to trust?
Is it from the branch I trust? And if all those checks pass, Azure AD then issues a regular short-lived Azure Access token back to the pipeline.
And the beauty is, no long-lived secret was ever stored in GitHub.
None. It's dramatically more secure. It's still a service principal under the hood, but the authentication method is token-based and passwordless.
That distinction is so important. For the exam and for the real world, you get the external access you need, but without the risk of secret sprawl.
Okay, moving on. Let's bring it closer to home for an administrator. Scenario 4. A script running locally.
Right, so an admin's on their laptop. They've got a PowerShell script they need to run to do some quick automated task.
The key identifier here is local script execution. The laptop is outside the Azure data center. It has no IMDS access.
So service principal, no question.
No question. Even if the admin could use their own user credentials to log in interactively, if the script needs to run non-interactively or on a schedule, it needs a programmatic identity. And on a local machine, that can only be an SP.
This logic extends perfectly to hybrid setups too, right? Scenario 11, accessing Azure from an on-prem server.
Yep. So you've got a Windows server in your own data center running a scheduled task. Maybe it's syncing data or pulling monitoring logs from Azure.
On-prem means it's outside Azure's control, no IMDS. Service principal.
Correct. And in this case, for a long-lived stationary machine like that, an SP gives you more security options than just a simple secret.
Like a certificate.
Exactly. You can configure the service principal to authenticate using a certificate you install on that on-prem server. It's a bit more work to set up and manage rotation, but it's inherently much harder to steal and misuse than a simple text-based secret.
So the SP serves as the bridge for any machine that Azure doesn't manage, whether it's a laptop, a GitHub runner, or a server in your own rack.
Absolutely. Now let's talk about another kind of external entity. Scenario 6, programmatic access for a third party.
Ooh, the vendor access problem. So you've hired a third-party company, maybe a security scanner, or a backup service, and their tool needs to connect to your subscription to do its job.
Classic external trust issue. They are, by definition, outside your organization. So managed identity is a non-starter.
It has to be a service principal. That's the only way to grant them access.
It is. And the administrator's primary job here is to lock it down. You have to use what we call highly scoped role-based access control, or RBAC.
So least privilege.
The absolute least privilege. Don't just give the vendor's SP the contributor role on your whole subscription. That's a huge mistake.
Right. You'd give them maybe just the specific backup reader role on just the one resource group they need to see.
Or even on a single storage account. The more granular, the better. The service principal is the object you assign the permission to, and your job is to make that permission as narrow as possible.
That's a great point. Choosing the SP isn't just about enabling access. It's about defining the boundaries of that access.
Okay, final one for the external group. Scenario 13. Temporary access for a migration script.
So the situation is a team is doing a big, one-time data migration.
Yeah.
The script needs high privileges, but only for, say, the next 10 days. After that, the access must be gone.
The key requirement here is that guaranteed controlled end date.
Right. And while you could try to build some complex process with MIs, the service principal has a feature built just for this.
It does. When you create a credential for an SP, whether it's a client secret or a certificate, you can set a defined expiration date on it.
And Azure AD enforces that.
Religiously. If that secret is set to expire at 11:59 p.m. next Thursday, any authentication attempt at midnight will be rejected, period. For temporary, deadline-driven projects, this is a much cleaner way to ensure access is revoked than relying on someone remembering to delete an identity later.
So to summarize this whole section, if it's outside Azure, on-prem, on a laptop, in a CI/CD pipeline, or if you need a hard-coded credential expiration date, The answer is always service principal.
That's the rule.
Okay, so now that we've firmly guarded the perimeter, let's step inside the Azure fabric.
Right. And inside Azure, the tables turn completely. The security mandate is clear. Managed identities are the preferred and often the required choice. They are the embodiment of the zero trust model.
And this is where we get to that zero secret configuration from scenario 12. Managed identities they eliminate the entire risk of leaked credentials.
They do, because there are no credentials for a human to see or handle. The whole process is automated. The Azure resource just asks its local IMDS endpoint for a token, and Azure handles the rest. The administrator never touches a password or a secret.
It's true passwordless access for your application.
It really is.
Okay, so we're inside Azure, we're committed to using a managed identity. But now the complexity kicks in again, because there are two types.
System assigned and user assigned. SAMI and UAMA.
And the AZ-104 loves testing the difference between these two, especially around their life cycle. So let's start with the default.
Let's do it. So scenario 1. A single virtual machine needs to get a database connection string from Azure Key Vault, and the hard requirement is 0 credentials stored on that VM.
The default, simplest, most secure choice here is a system-assigned managed identity, the SAMI.
Correct. But why SAMI specifically? A UIMI could also do the job.
That's the question. Why is SAMI the best choice here?
It's because its life cycle is directly and inextricably tied to the resource it's assigned to.
What does that mean in practice?
When you go to that VM in the portal and flip the switch to enable a system-assigned identity, Azure AD creates a service principal object in the background that represents that VM and only that VM. It's a one-to-one relationship.
And the lifecycle part.
When you delete that VM, Azure automatically cleans up and deletes that identity for you. You have 0 management overhead, 1 resource, 1 identity. When the resource is gone, the identity is gone.
That seems perfect. So why would we ever use anything else?
Well, that tight coupling is a double-edged sword. What happens if the resource is supposed to be disposable, but the identity and its permissions need to stick around?
Okay.
Which brings us to the counter scenario, scenario 9. A long-running process that has to survive its host being recreated.
So imagine a critical API running on an app service. It uses its identity to manage data in a SQL database. Now, what happens if you have to delete and redeploy that app service, maybe for a disaster recovery test?
If you used a SAMI, deleting the app service would destroy the identity. All the RBAC permissions you assigned to it on that SQL database would be gone.
Which means your redeployed API would fail to connect. You'd have a service interruption until you manually went and reapplied all the permissions to the new SAMI on the new app service.
A total outage. And that's where the user-assigned managed identity comes in. The UAMI is the correct choice here for persistence.
Why? How's it different?
A UAMI is created as its own separate top-level Azure resource. It has a lifecycle that is completely independent of any VM or app service.
So you create the UAMI first.
Exactly. You create the UAMI, you assign the necessary SQL permissions to it once, and then you attach that UAMI to your app service.
So now, if the app service gets deleted,
the UAMI is completely unaffected. It's still there, holding on to all its precious permissions. When you deploy the new app service, you just reattach the existing UAMI to it, and everything starts working instantly.
So UAMI gives you identity lifecycle independence. That's the key differentiator.
That is the core concept the exam is testing. SAMI's lifecycle is dependent, UAMI's is independent.
Okay, so beyond persistence, what's the other big reason to use a UAMI?
Reusability and managing complexity at scale. SAMI is one-to-one, UAMI is one-to-many.
Let's use scenario 3 to illustrate that. Yeah. You have a web farm of, say, 12 identical VMs. They all need the exact same access to read a configuration file from a central storage account.
Okay, if we use SAMI on each one, what does that look like from a management perspective?
It means we have 12 different identities. So we have to go to that storage account and assign the storage blob data reader role 12 separate times, once for each VM SAMI.
And that is a recipe for disaster. It's what we call security drift. You miss one, or you forget to remove permissions from one later. It's just a huge administrative burden.
So the correct choice is a user-assigned managed identity.
Right. You create one UIMI. You assign the storage reader role to that UIMI one time. Then you attach that single UIMI to all 12 of your VMs.
And just like that, you've simplified your security governance.
Massively. Instead of 12 points of administration, you have one. If you need to change permissions for the whole cluster, you change it in one place on the UAMI, and it instantly applies to all 12 machines.
We see this exact same pattern with platform as a service offerings too. Scenario 8. 10 different app services all need the same access to Key Vault.
It's the identical architectural problem. Using 10 SAMIs creates RBAC sprawl and a management headache.
But with the UAMI, you assign the Key Vault secrets user role once to the UAMI and then just attach that same UAMI to all 10 of your app services.
It's an administrator's dream for scaling security and making sure least privilege is applied consistently everywhere.
This pattern is so powerful it even works across the globe, which brings us to scenario 14.
The multi-region app.
Right. A critical app deployed in 3 different regions for North America, Europe, Asia. All 3 instances need the exact same permissions to work.
When consistency is that critical, UIMI is really the only sane choice. Imagine trying to keep 3 separate SAMIs in 3 different regions perfectly in sync with their permissions. It's brittle.
But with a single UMI, you guarantee that the identity and its permissions are uniform everywhere. Your security team audits 1 identity, not 3.
It's the cornerstone of scalable, clean architecture.
So the lesson for SAMI versus UMI is, if the identity is disposable and tied to a single resource, SAMI is your go-to. If that identity needs to be persistent, shared, or managed centrally, you have to use a UMI.
You've got it.
All right, let's talk about some of the more modern workloads. This is where I think some people get caught out by, outdated knowledge.
Yeah, this is a big exam trap section. A few years ago, some of these services didn't have great MI support, so people got used to using service principals. That's not the case anymore.
Okay, let's start with scenario 5. An Azure function. It's running on a consumption plan, so it's ephemeral, and it needs to access storage in Key Vault.
The old insecure way was to put a connection string or an SP secret right in the function's app settings.
A huge security no-no.
A massive one. Today, the correct choice is a system-assigned managed identity. Azure functions, even on the cheapest, most ephemeral consumption plan, have full native support for MIs.
So the second you enable that SAMI on the function, it can securely get tokens from IMDS and talk to other Azure services without ever seeing a secret. The exam wants you to know that MI is the standard now.
It is. And the same thing goes for containers, which can feel even more temporary. Scenario 7, a container running in Azure Container Instances, ACI.
So a container that spins up, does a quick data processing job, and then disappears. It needs to pull data from Azure storage.
ACI is inherently short-lived, but it still has native support for the IMDS mechanism.
So you can use a managed identity.
You can, and you should. Typically a SAMI, since the container instance itself is disposable, so the identity can be too. This lets you avoid passing secrets into your container as environment variables, which is a notoriously insecure practice.
This really highlights the power of the platform. Even for a workload that might only exist for 30 seconds, Azure provides a secure, credential-free way to access other resources.
It does. And it provides that stark contrast we talked about. If you were running that exact same container on-prem in your own Kubernetes cluster,
you'd be forced to use a service principal. Back to the location rule.
That's the boundary that proves you've mastered this. Okay, last one in this group. Scenario 10, Azure automation accounts.
Runbooks. So long-running scripts for maintenance and scheduling that need to touch resources across our subscription.
Historically, these use something called run as accounts,
which were really just service principals with certificates that you had to manually rotate. A real pain.
A huge pain. And that whole method is now deprecated. Today, automation accounts have full support for managed identities.
So you enable an MI on the automation account, and the runbooks can authenticate to Azure resources without any certificate management.
Exactly. You completely eliminate that maintenance headache. It's a huge simplification for admins.
But let's bring back that skeptic's challenge. What if that runbook, running in Azure with its MI, needs to talk to something that isn't Azure? Like, it needs to update a ticket in an external ServiceNow system.
That is the critical nuance. The MI is for authenticating to Azure AD-backed resources. It's useless for that call to ServiceNow.
So for that one external call, the runbook might still need a traditional credential.
It might. It could use its MI to securely fetch a ServiceNow API key, which is stored as a secret in Azure Key Vault. It then uses that key to talk to ServiceNow. So the identity for Azure is the MI, but the identity for the external system is still a credential.
The identity mechanism is always dictated by the destination you're trying to reach.
Always.
Okay, we've gone through 15 different scenarios. That's a lot to hold in your head during an exam.
It is. So let's synthesize it. Let's boil it all down into a rapid, structured decision tree that you can use on the fly.
I like it. Give me the 3 questions I need to ask myself when I see an identity scenario.
Question 1, the absolute first line of defense. Is the workload running in Azure? Can it talk to that local IMDS endpoint?
And if the answer is NO, we stop right there. It has to be a service principal.
It has to be. That covers your GitHub pipelines, your local scripts, your on-prem servers, your third-party vendors. If the answer involves managing secrets or certificates, it's an SP. That's the easy filter.
Okay, but if the answer is yes, it's running on a supported Azure resource, then we go to question 2.
Question 2 is the lifecycle test. Is the identity tightly coupled to one resource, or is it a shared persistent identity?
If it's tightly coupled, one VM, one function, and the identity should be deleted when the resources, we default to system-assigned MI, SAMI.
And if it's shared across many resources, or it needs to be persistent and survive its host being deleted, we must choose user-assigned MI, UIMI.
That's the management scalability decision.
Okay.
And the final tiebreaker.
Question 3 is the ultimate security question. Does the requirement specifically call for fully automatic credential rotation managed by the platform?
And, as we covered, if the requirement is automatic rotation or zero exposed credentials, managed identity is the only game in town.
The only one. A service principal's credentials always need some form of manual or scripted rotation.
That 3-step process location, lifecycle rotation is a fantastic mental model for the exam.
It'll get you to the right answer 95% of the time.
But let's talk about that tricky 5%, the exceptions. When might an SP be the right call, even if the workload is technically running inside Azure?
There are 2 main exceptions to remember where the nature of the access is more important than the location.
Okay.
First is that temporary project from scenario 13. If the absolute hard requirement is that access must be revoked on a specific date and time, only the service principal's credential expiration can guarantee that with a technical control.
Right. It's not relying on an admin to remember to do something. The credential just stops working.
Exactly. So if you see words like deadline or hard expiration, your brain should think SP. The second exception is that nuance from the automation account scenario.
When an Azure service needs to talk to a non-Azure system.
Right. If you have an Azure function whose primary job is to interact with AWS APIs or some on-prem system that only understands a client's secret, then an SP might be the simpler identity to manage for those specific external calls. The MI gets you into Azure resources, the SP gets you out to everything else.
So it's about connectivity to systems outside the Azure AD identity universe.
Mastering those exceptions is what takes you from just knowing the rules to really understanding the architecture.
This has been incredibly helpful. We've really broken down these 15 scenarios, and I think that focus on location internal versus external and then lifecycle tied versus shared is the key.
It is. Those patterns are the shortcut to acing the identity section. Remember, the GitHub pipeline needs an SP with OIDC. The single VM defaults to a SAMI. And that multi-region app absolutely requires the independence of a UIMI.
We've talked a lot about the biggest benefit of managed identities being that automatic rotation. It's a huge security win because the credentials are never exposed.
A massive win. But it does raise an interesting, more advanced question, something for you to think about after the exam.
Go on.
If the keys are never visible to you, and Azure handles the rotation process completely behind the scenes, how does a company in a highly regulated industry like finance or healthcare prove to an auditor that the credential rotation actually happened every 90 days like their policy requires?
Wow. That's a great question. The administrative problem shifts completely. It's no longer, did we remember to rotate the key?
It's how do we get compliance evidence for a process that the platform has completely abstracted away from us?
It forces you to find new ways to prove compliance, maybe through Azure policy reporting or digging through specific audit logs, to verify that the platform is doing what it promises.
That's the next level of cloud governance, learning how to audit the abstraction layer. And we'll leave that thought with you.
Thank you for joining us for this deep dive. We hope this battle pack helps you nail your exam and, more importantly, secure your cloud environment. We'll catch you next time.